This is CPM Precalculus Chapter 2, number 13. So let A equal to the point -2, 5, and B equal the point 5, -2. So part A is to find the distance between A and B. Okay, so this one's pretty straightforward. We need to use the distance formula to find the distance between A and B. And that's going to be the square root of, in here we have delta y, or y2 minus y1 quantity squared, plus x2 minus x1 quantity squared. So we want to find, this is the distance, and these are the 2 points. So we could choose either point to be number 1 and number 2. I'm going to choose this to be number 1 and this one to be number 2. That means this is going to be x1 and this is going to be y1, right? And this then is x2 and y2. Okay, so now I'm going to plug these values in. So y2, I look up here, y2 is 5. So from point number 2, the y value. So we have 5 minus, and y1, from point number 1, the y value is -2 squared. Okay, don't forget the square. Plus x2, number 2, x value is -2 minus x1. x1 is 5. Again, squared. Okay? So the thing to make sure to do is when I have a subtraction of a negative, I make that into a positive, right? 2 negatives make it into a positive. So 5 plus 2, I know 7. So 7 squared plus -2 minus 5 is -7 squared. Okay? So let me bring out my calculator. Some of you might think like, oh, 7 squared, I know it. 7 squared, 49. Yes. So I get 49. Okay, and let's put in -7 squared. Now I'm going to do this right like this, so -7 squared. This looks like what I want it to be, but when I do it, I get -49. But I know when I multiply a negative times a negative, right? If I multiply a negative times a negative, it's equal to a positive. So this should be positive 49. So what's my calculator doing? So let me just go over this really quickly. When I do -7 squared, it's doing this with the calculator. The calculator is going to put negative on the outside, and it's going to do exponents before making it negative. Okay, so in order to make this correct, we're going to have to put it -7 in parentheses and then square it. Okay, -7 then is going to be -7 times -7. So remember, the calculator is pretty simple, and it follows the parentheses, exponents, multiplication and division, addition and subtraction order. Okay, so then I get 49 plus 49 and the square root of that. Okay, and I can now add those together and I get square root of 98. So the distance between A and B is square root of 98. Well, I know this is 49 plus 49. So before I did this step, I just want to show you that I could have done, so let me undo this step. I could have done this, right? I could have said 49 times, I could have factored out 49 and had 1 plus 1, right? And that's just the same as 49 times 2. And I know the square root of 49 is 7, so I could have pulled 49, the square root, out as 7, because this is the same as square root of 49 times square root of 2. And square root of 49 is 7, and then we still have square root of 2, right? Or up here, let me put a line here. I said that was equal, if I add them, I get square root of 98, right? I could still divide 98 by 2. In my calculator, 98 divided by 2 is going to be 2 times 49. And that would help me do the same thing. That's equal to square root of 2 times square root of 49. And I know square root of 49 is 7. I could put that in the front. And it's the same. Okay? So this is part A. This is the distance in units. The distance between points A and B. And I could put in my calculator even and get 7. Oh, I did this totally wrong. This is 7 times square root of 2. right? Because square root of 49 is there and square root of 2 is there. Okay, so 7 times square root of 2. So I could say it's 7 square root of 2 units, or approximately 9 point. So where do I want to round? I could put this whole thing, right? That's going to give me a lot of accuracy and precision. But I can just put it to 8, 9, right? But if I want to round there, I have to look at the number next to it, and that 9 makes this round up. So I have to make that into a 90 then, right? So if I want to round 2 digits after the decimal place, I have to make it 0.90. So either one of these answers, or both, is going to be for part A, finding the distance between A and B. So let's go to part B. Part B is asking us to write an equation for the line passing through the 2 points in point-slope form. Okay, so that's y minus y1 equals to m times x minus x1. And slope-intercept form, which is y equals mx plus b. Okay, so to write the equation of the line, I need a point and a slope. Well, what is the slope of my segment AB? The slope, little m, and I'm going to put a little subscript AB, so I know I'm talking about these points, is going to be the change in y over the change in x, right? And again, it doesn't matter which is number 1 and which is number 2. So now I'm going to say that's number 1, that's number 2. So that's x1 comma y1. And that's x2 comma y2. And y2 is negative 2. y1 is 5. So I have negative 2 minus 5 over x2 is 5 minus x1 is negative 2, right? Negative 2 minus 5 is basically, you could do this if you want, it's plus and negative, so it's negative 7 over 5 minus negative 2 becomes positive, right? Because minus a negative becomes plus positive over 7. Negative 7 over 7, right, is just negative 1. So there's our slope, right? Our equation for the line passing through points A and B. So I want this slope, and then I can use either one of these points. No matter which one I'm going to use, I'm going to get the same equation. So if I use point number 1 right here, and I plug it into my point slope form, I get y minus, well, what is y1? 5 equals to, what's the slope? Negative 1 times x minus x1. Well, x minus negative 2, right? Which is, if I just simplify this, it's going to be y minus 5 equals negative, right? I don't need to write a 1 there, x plus 2. Okay, so that's if I use point number 1. Okay, and that's point slope form. What if I use point number 2? Use number 2. Then I would get y minus the other point's y, which is negative 2. Negative 2 equals to our same slope, negative 1 times x minus the x value here, 5. I can simplify this. This is going to just be y plus 2, right? A negative minus a negative is plus. I don't need to write the 1, x minus 5. So either one of these answers is correct. And actually, both of these are the same. And we can see that because we also need to answer and give the slope-intercept form. So that's just solving for y. If we were to solve this equation for y, we get slope-intercept form. So let's do it with both of them, and to see and to show we're going to get the same slope-intercept form on for our equation of the line. So y minus 5 equals to, now let's distribute the negative. So that negative goes to the x, negative x, and the negative goes to the 2, plus negative 2. Okay, add 5 to both sides, and I get y equals to negative x plus 3. Okay? So this is the slope-intercept form of this line, right? And let's say I started here. Well, y plus 2, let's distribute the negative. Negative x, negative times negative is positive 5. Minus 2 from both sides, right? And I still get y is equal to negative x plus 3. Okay, so either way I did it, if I use the point number 1 up there or point number 2, I get the same line. These are all equivalent. This one, these are all the same. Same. These both are in our point slope form, and these both are the same, and they're in the slope-intercept form. Okay, and you can see clearly that the slope is -1, right? And the y-intercept is 3. All right, this ends CPM Precalculus Chapter 2, number 13.